If your API is going to be called by browsers, such as for single-page applications or SPAs, then you may need to configure Cross-Origin Resource Sharing, or CORS. You'll also most likely want to configure your API to support HTTPS, and ideally only HTTPS. Cross-Origin Resource Sharing is defined in RFC 6454. By default, browsers enforce a same-origin policy, which means web pages cannot make requests to a different domain than the one that served the web page in their JavaScript. Two URLs have the same origin if they have the same scheme, host, and port. CORS allows a browser to load resources from other origins. Note that CORS is not a security feature per se. It actually is a way to relax security so that certain apps, such as single-page applications, can access an API hosted at another origin. Remember that CORS configuration occurs on the API server, not on the client server. To configure CORS, you need to add it to your application's services and specify a policy. Only enable CORS for the specific hosts that include apps that must access your APIs in the environment where the app will be hosted. If you have multiple dev, stage, and production environments, you should configure each one's policies specific to that environment. Once the service has been added and configured appropriately, you must add middleware and specify the policy name used in the service definition, unless you're going to use the default, which we'll see in a moment. CORS middleware should appear after HTTPS redirection and routing middleware, but before authentication, authorization, caching, and any endpoint mapping middleware. If you'll be using JavaScript to retrieve static files cross-site, then use CORS must appear before use static files. Otherwise, it's better to place it after it. If you don't need separate policies, you can simply define the default policy and then call use CORS without any arguments. You do this by calling add default policy instead of add policy. In many cases, you're only going to need a single CORS policy, so this is the best approach to take. If you don't define a default policy, then the call to use CORS in the middleware will do nothing. CORS policies can include three components. They can specify origins, either specifically or using wildcards if used with the set origin allowed to allow wildcard subdomains. That's a mouthful. Policies can also specify allowed methods, such as put, post, get, delete, etc., and they can specify allowed headers. All of these can support allowing any. However, you should take care to be as restrictive as you can with your CORS policy to prevent cross-site request forgery attacks on your API. Browsers normally restrict response header access to a small set of simple headers for cross-origin requests. If you want to allow clients to access more headers, you must specify them with the with exposed headers command. Also, by default, browsers do not send credentials when requesting cross-origin resources. Application scripts can be specifically set to request credentials, but for this to work, you must also have the server set up to allow credentials. Credentials include things like cookies and HTTP authentication schemes. Remember, for optimal security, you should only enable CORS access to your APIs for specific hosts, methods, and headers needed by your API's clients. For even more granularity, you can configure CORS on a per endpoint basis. At the MVC controller or action level, you can use attributes to enable CORS for a specific policy or to disable CORS if you specified CORS at a higher level at the controller or global level. Minimal APIs can use the same attributes, allowing you to specify CORS using a lambda expression as usual and a enable CORS attribute applied to it. For most APIs that are not sitting behind a proxy server, you should be requiring HTTPS. ASP.NET Core has a require HTTPS attribute, but it is designed for browsers and is not well suited for APIs. You should avoid using it for your API projects and controllers because it relies on URL redirection to work. It returns a 302 found and expects that the browser will follow that to the secure option. API clients may not pay attention to 302 found responses, and therefore may not redirect as expected. What's more, the original request might have sensitive data in it, so even before the API is telling the client that it should use HTTPS, it may be too late if they've already sent sensitive information like passwords using HTTP. A better approach is to reject all HTTP traffic entirely. Don't even return anything so that their connection cannot send the request. Optionally, you can choose to accept them but return a 400 bad request. What about HSTS? HSTS stands for HTTP Strict Transport Security and is defined in RFC 6797. It sends the Strict Transport Security response header indicating to browsers that they should use HTTPS. It relies on client implementation. Browsers typically implement this, but native apps typically do not. As with the HTTPS requirement, it's better not to accept insecure requests in the first place than to try and use a middleware solution like HSTS, which is defined for browser use. The recommended way to ensure your API only accepts requests using HTTPS is to put the API application behind a reverse proxy and only forward on requests that are using HTTPS. In some configurations, a reverse proxy handles all HTTPS traffic, and behind the proxy, all traffic uses HTTP for performance reasons. Be aware of the security trade-offs that this approach may bring with it. You can also simply configure your application to only listen to HTTPS requests. Any non-HTTP request will be rejected before your application is even aware of it. One way to specify the URLs your app will listen on is to use the useURLs method on the web host in program.cs. With this approach, you can add a comma-separated list of URLs. Just make sure they all include HTTPS. You can also configure your app's startup URLs that it will listen on using environment variables. The ASP.NET Core _URLs environment variable can be set to include one or more URLs. This is a useful approach, especially when combined with Docker containers and/or cloud app services. Remember, for API projects, it's better to simply reject HTTP requests completely than to accept them and try and get the client to redirect to use HTTPS. Avoid using require HTTPS and use HSTS in your API projects. Let's review. In this module, you learned the basics of how to secure web APIs using JSON Web Tokens, or JWTs. You saw how to use JWTs properly, including important concepts related to validating JWTs to ensure they can be trusted. You also learned a couple of alternatives to JWTs, such as using Windows authentication or a BFF server combined with cookie-based auth that keeps tokens on the server side rather than allowing the client to deal with them. You learned how to implement authentication and authorization using ASP.NET Core, and then you saw how to leverage CORS to allow access to your API resources from browser code, as well as how to ensure your APIs are only accessed securely using HTTPS. Up next, we'll finish up this course by showing how to test your ASP.NET Core web APIs. Hi there, I'm Steve Smith, and welcome to this final module where we're going to look at how to test your web APIs using repeatable, automated tests and some best practices for making those tests as maintainable as possible. This will be a fairly short module to wrap up this course. Testing of web APIs is one of my favorite features of ASP.NET Core because it's so much better and easier than this was possible to do with prior versions of ASP.NET and ASP.NET MVC. We'll start out by showing how to set up web API tests using built-in test server and the Web Application Factory class. Then, we'll take a look at how to set up your system with test data that's consistent for every test run. This is something that trips up a lot of folks when they're first getting their tests working, so I want to give you some examples that are proven to work for my code. And then finally, we'll look at how you can use helpers to improve your tests and make them shorter and easier to maintain.